Everyone, my name is Ayush and I'm from DevOps Competency, and today's topic is Terramate. So let's start with the knowledge certificates. So first is punctuality. Please join the session 5 minutes prior to the session start time. We start on time and conclude on time. Second one is feedback. Make sure to submit a constructive feedback for all the sessions as it is very helpful for the presenter. Third one is silent mode. Keep your mobile devices in silent mode and feel free to move out of the session in case you need to attend an urgent call. And last one is avoid disturbance. Avoid unwanted chit chat during the session. So let's see what are the agendas for today. So first is what is Terramate, then components of Terramate, common use case of Terramate CLI, Terramate versus Terragrant installation, and then lastly is demo. So, okay, what is Terramate? So basically, Terramate is an open source tool that enhances Terraform by adding powerful capabilities such as code generation, stack, chain detection, and globals. It is designed to help developers to manage multiple Terraform stacks more efficiently and to keep their configuration correct. So generally, writing Terraform configuration file is easy if you have a small code base or a small infrastructure to work upon. But as soon as your infrastructure and code base size increases, it becomes difficult to maintain all the things. And sometimes this may lead to error in the infrastructure due to minor changes made by a developer on only one environment. So basically now how to solve this? So basically we can use Terramate, that is one of the tool to resolve this problem, and that use the code for dry. Dry means don't repeat yourself. So basically dry principle promotes code reuse and modularization, and by following the dry principle, developer can reduce code duplication and enhance the code readability. And Terramate is a tool that can help you maintain the dry principle in your Terraform code. So that's about what is Terramate. So next are the components of Terramate. So first component is stacks. So basically Terramate allows you to split your Terraform state into multiple isolated stacks. This can make your Terraform code more manageable and organized, especially in large project with many resources. And next one is data sharing. So Terramate support data sharing through a use of globals. Globals are basically user-defined entities that allow you to define data once and distribute it throughout your project. And the next one is code generation. So Terramate support code generation of Terraform or Excel code. This can help you to keep your configuration dry and maintainable. And the next one is change detection. So basically, it monitors changes in Terraform code and automatically applies them, minimize manual intervention and potential errors. So we will be covering all these components in the demo. So please wait till then. And the next one is common use case for Terraform CLI. So first one is implement and maintain highly scalable IAC projects. So as I talked about stacks, so basically stacks unlock faster execution, better collaboration, and lower blast radius risk. This stack like parallel deployment ensure no more pipelines and bottlenecks. And next one is deploying significantly faster and more often. So change detection allow you to execute only commands in stack that have been changed in the current branch or since the last merge, reducing CI/CD runtime to be bare minimum, even in complex environments. So basically, it helps us in cost saving and it improve our throughput. So, so next one is Terramate versus Terragrant. So Terramate and Terragrant both are software tools that are integrated with Terraform in order to help you keep your code base dry. Basically, they help in running Terraform code in multiple environments at once and help to avoid manual writing to the code in each environment. So, so there are the this is the comparison between Terramate and Terraform. So first is ease of use. So like while you are using Terramate, if you want to make free environment or stack, you first need to create a stack and put it inside the module directory. Write only the generate block, which will be used by stacks to generate the code. So for that, we can use a command terraform create and name of the environment that you want to create. But for Terragrant, we have to manually create all the environments separately and have to write the configuration file for each environment. And next one is cloud providers. So both of them have similar and same cloud providers. Next one is syntax highlighting. For that, as you can see in the image, on the left side the syntax is for Terramate, and on the right side is the syntax for Terraform. As you can see, for Terramate, it's likely readable and as compared to Terragrant, and kind of in Terragrant, like it's kind of boring and it's not like that easy to read as compared to the Terramate. So next one is change detection. So one of the best feature for Terramate, I would say, it is change detection. As working with a Git-based environment, you can check for what infrastructure is changed and apply your Terraform command only to that particular change infrastructure. And Terraform offers change detection by typing a simple command. It detects all the changes made on the infrastructure and applies all the desired Terraform commands only on changes. And for Terramate, it doesn't support anything like that. We have to manually apply the changes one by one for each of the environment. That is kind of hectic. And the last one is uniform code. So like in the case of Terramate, whenever we make a new stack, we don't need to do anything explicitly to involve it in the environment. We For example, like we made three environment stacks that are suppose dev, prod, and staging, and generates a Terraform configuration for each of the stack. And later we thought to make one more stack named testing, and this must also include all of the configuration that are defined in other stacks. So what we can do, like we simply make a new stack, and the configuration file will get auto generated in this new stack as well along with the other stack. And for the Terragrant, as I always said, that we have to manually write the configuration file for each of the environment, and then we have to write Terragrant in it. And if we don't write the configuration for each of the environments separately, so it won't be considered it when running for all the environment. So yeah, so you need to explicitly enter environment and run the command to make the code uniform if you forget. So that's about Terraform as a Terraform as a Terraform. So next is the installation. For installation, I already write a script for that. So in the script, I'm using a directory and then storing the URL for the tar file, and then curling this, and then extracting, and then exporting its part in the .bash RC. So that's how we install Terramate in our system. And the last part is the demo. So like before, so first we have to configure. We have actually two ways to configure it. So firstly, what we can do, like if we invoke the Terramate inside a Git repo, it will automatically assume the top level of your repository on the project root. On second one, like if we want to use Terramate directory that is in the repo, we must configure the project root by creating a Terramate tm.hcl file by and configure it on the top root project in our Terramate project. So for that, what we can do is we can create a file known as terramate.tm.hcl. So basically, Terramate recognize any file with the tm.hcl extension. Inside it, we will write Terramate config, and then we can write the command Terramate create my site. My site can be any stack you want. So for my stack, I'm using the name my site, and as you can see, stack is created. So it's created a directory known as my site, and inside that my site directory, we have a stack.tm.hcl, and let's see what is inside it. So there are few things inside the stack. So these things are name, description, and ID. So basically, IDs are unique for each and every stack. As I mentioned, stack are the isolated environment, and basically Terramate uses the file system as a hierarchy and needs to know the project rule. So this is one of the features that I component that I explained earlier. This is stack, and next one we what we can do is that code generation. So what we can do is uh, I have already add some code. So let's go and just copy this and paste it here. So now what we can do, like we will run the command terramate generate. So as you can see, success. So it automatically generated the Terraform code for us. So inside the code you can see. So it is basically using the Terraform local file resource, and it's to create a file name index.html in the temp directory. So with the help of code generation, you rather than manually writing code in each and every environment, you can simply write code once, and then you can write this command terminate generate to generate the code for each and every environment. So like as you can see, there are few of the values like title. So for this now we only have one directory or one stack, so it is easy for us to write this. Like suppose if we have multiple environments, for that what we can do, we can use the value global. So for global we can write globals .tm.hcl, and inside it what we can do, we can write a global block labels, and then title, we can add title like this is first website, and after that what we have to do, like we have to use that global environment inside our uh, stack file. So here you can see inside title you can write the environment global dot title that we use. And to generate this code once again with the new value, we can write terramate generate. As you can see, it's successfully created. We can go and see what is the value for the title. Yeah, so it is changed to this is first website. So that's how global works. If we want, like we can use it in different environments. For different environments now, like let's do a modularization the code. For that, what we can do, we can create a module folder for that. Modules my site, and then we can move all the files from my site folder to the module one. Yes, my site dot p, and then we can the file is present inside the my site folder. So here you go. We only have a folder known as module. So modularization the code is one of the best feature we can use for the different environment. So now let's create two different environments or stack. Terramate create. Let's call it dev my site, and other one would be Terramate create for my site. Okay, as you can see, both of the directories created. And if we go inside dev, inside my site, and this is stack. As, okay, as you can see, the ID is unique and different from the previous one. That will be same for the prod as well. If I go check, yeah, so they both are different. So let's see how the directory structures look like. So for in this we in this inside dev we have a my site folder and then the stack file. Same for the prod as well. So now, but we can do like suppose we want the my site stack under the dev environment to customize. Basically, there are several ways to do that. One we can do is like we can create globals inside the dev folder. So let's go and make some changes. Dev site. So we can create a file known as dev.em.hcl. As I earlier said, Terraform recognize any file that has the extension of em.hcl. So we will do the same as we did earlier. Globals, and let's env would be dev for dev, and we can do similar for the prod one. Prod.em. So globals env would be prod. So we made the changes for both the environment. So with this change, any stack we put under the prod directory will now inherit globe.env is equal to prod, and the same for the dev environment. And now what we have to do, like now, like suppose we want a stack in each environment to import the my site that we used in our module. As I earlier said, we are modularizing the code, so we have to make changes inside our module folder. And before that, as I mentioned earlier, I have to import the sources inside the inside each of the environment. So we will go now and we will import the source path for that. Source will be modules inside and we have to do the same for the prod as well. Import the source same as the dev environment. So yeah, we made the changes, and now what we can do is the only fix we need now is the output file name for the local file. As right now we are hard coding the file, meaning like dev and prod will overwrite each other to resolve. To resolve this, basically we could use the global env inside the environment. Like we can go and make some changes, or we can what we can do like inside our module. What we can do is we can write global.env So with this, like it's storing each of the environment separately in their own directory rather than overriding each other. So we are done with it. So now we will write the command Terramate generate. I guess okay. So there is some issue with the path, I guess. So what we can do, like I already use this, so we can easily import this file. Either we can make changes here only. Same as for the prod. Okay, got it. So basically now as I'm using module, so I don't need the stack here as I don't want to create any, or I don't want to generate any code for it. So we can remove it. So now here we go. So for that now it's showing the success for the dev dev environment and for the prod, and for minus means that it deleted the file from the module as we don't need any file for the module, and we only need file for our Terraform, only file for the particular environment. So as both the code generated for both the environments, we can switch to the dev environment. Here you can see the Terraform file is created. So let's go and see what's inside it. So yeah, as you can see, title is this is first website, and the file name and the path will be tm tf my site and dev environment for the dev one, and for the prod it will be yeah, as you can see it's prod for the prod one. So it did not override it, and it created a separate environment folder for each of the environment. Now basically there are two things you can do. You can easily use Terraform basic command like Terraform in it, as you can see. So it initiated the Terraform inside the dev environment, but now we don't have to use this way. The easier way and the most crucial way would be to write this command Terramate run Terraform init. So what this command do is like rather than using Terraform init for each and every environment separately, we can write this command to run the Terraform command from the project root rather than for each and every environment. So as you can see, it initiated it for the two environment for prod and dev. And if I do Terraform Terramate run Terraform plan, so it will show the output of the plan for both of the environment, for prod and as well as for dev environment. So that is one of the features of Terramate. And the next and one of the most important feature I would say is the change detection. So basically, change detection is expected to be run in a CI/CD pipeline and requires a working Git with a remote repository. So let's do it in our uh, project root only. So first we will initiate it, then let's add all the files that is necessary, and we will commit it with first commit. And now what we can do, let's set up a temporary local git remote. So I have already write the code here. So before that, what we can do, like we can change the branch name from master to main. Master. Let's check this out. Okay, so it's main. Now, as I was saying, let's set up a temporary local git remote. Then we will set our origin, and then we will push it So yeah, it is successfully pushed. Now we will create another branch from the main. So here's now the interesting things come. So let's suppose if we want to like override my site title only in the dev environment. So what we can do is we can go inside our dev environment. Inside that we can write title. Uh, this is dev. So we made changes only in the dev environment. And like as we build more complex stacks, seeing how the globals are evaluated in stack can be helpful. For that, what we can do, we can write a command that is Terramate experimental globals. So as you can see, the values for globals in each of the environment is present here. For dev, it is dev. This is dev, and for prod, it is this is first website. So basically, it follows an hierarchy. If we don't mention anything inside the environment itself, it will look for it outside the that directly into the root one. So in the root, I have mentioned this is first website. So automatically, it is assigning title from there only. So now we will generate the code. Generate. So yeah, as you can see, it is only creating the Terraform file, a TF file for the dev file. So here we go. So it made the changes. This is dev. Now let's add the changes. Commit the name am sorry am website change dev title. And now what we can do, we can use a command Terramate list icon change. So it will show in which environment we make the changes. So it is showing dev my site. So let's now in the command Terramate run icon change Terraform Terraform plan. So as you can see, it is only creating the file for the dev environment. So while developers are working on different environment, so for like, suppose someone is working on a dev environment only, so he can make the changes on that particular environment and can apply file uh, to that particular environment only, rather than changing all the configuration from the other environment. It's better to work on that particular environment and apply changes to that only. So that's some of with Terramate. So basically, Terramate, I would say Terramate is very flexible, and actually there is a lot more to explore it. So that's all from my side. I hope you get the gist of it.
Thanks, Ayush. Guys, do we have any questions? Anybody, any questions? Guys, please do not forget that Ayush will also be nominating two of you as the spotlight nashers, and this is your time to earn some brownie points in Go 1%. So if you want to have some clarifications or questions around the topic, or if you want to discuss something about the topic, you can please feel free to ask. Anyone? Do we have any questions? All right, then, Ayush, I think we are good to close the session. So, thank you so very much for the wonderful session. And thank you, everyone, for attending the same. See you all next week.